Hey everybody, Rob Maurer here, and today we are talking all about Tesla's Battery Day, the event that we have all been waiting for now for about a year and a half. We've made it through 3 or 4 delays, but Tesla's Battery Day is finally almost here. We've talked about these topics for months, but here is everything consolidated into one nice episode, everything that we should be expecting from Battery Day. We'll start off with the battery cell. Tesla has been teasing since last year's annual shareholder meeting that they will further vertically integrate throughout the battery supply chain and start designing, developing, manufacturing their own battery cells, allowing them to introduce new technology in both the battery cell, increasing performance, and the manufacturing process, lowering cost. And while supplier margins on battery cells aren't massive, Tesla cutting those out in the cases that they can, won't be every case, we'll talk more about that later, but when they can cut that margin out, that'll reduce costs as well. As for the battery cell itself, the expectations are for Tesla to introduce a larger form factor cell, similar to what they did when they introduced the Model 3 with the 2170 form factor, which just stands for a cell with a diameter of 21 millimeters and a height of 70 millimeters. That was larger than their previous cell, which was 18650, 18 millimeters by 65 millimeters. As we discussed in yesterday's episode, Electrek recently obtained a photo of a battery cell that is much larger than a 2170 cell, which Electrek believes, after having confirmed with multiple sources, is Tesla's new battery cell. Yesterday, we hypothesized that this cell could be 54 millimeters by 98 millimeters. Looking back on it today, I think that the mock-up that I made is a little bit bigger than what is pictured there from Electrek. So instead of being 54 by 98, I actually think this cell is probably closer to something like 45 millimeters by 75 millimeters. We can use those dimensions to calculate the volume of these cylinders respectively, and we find that a 45 by 75 millimeter cylinder contains about 5 times as much volume as a 2170 cell. With a cell that is 5 times as large, that means that instead of putting about 4,000 cells into a battery pack today, Tesla could reduce that to under 1,000. That has huge implications for manufacturability, which we'll get to later. The other main advantage of a larger cell is the improved energy density, particularly at the pack level, because these cells are surrounded in casings. So the more cells that you have, the more of your pack is actually dedicated to the volume and weight of those casings, rather than the active ingredients in the battery. So a larger cell is generally better, but there are downsides to a larger cell. Based on the way batteries are traditionally constructed, the larger volume of a cell means that the electrons and the ions, as they move around in the cell, have to travel larger distances. That generates more friction, which generates more heat, which is a huge limiter on lots of different functionality of the battery, from performance to life cycle. That leads us to Tesla's tabless battery cell patent, which Elon on Twitter has said is more important than it sounds. And the reason that he says that is believed to be because that tabless battery cell design reduces that distance that needs to be traveled by those electrons and ions in a larger battery cell, reducing that additional heat that you would normally get from that larger format cell. So if that's the case, Tesla can capture the advantages of a larger format cell while limiting those disadvantages. And as is becoming a common theme here, which again we'll come back to, it should make the manufacturing process much easier. So it's my opinion that both a larger cell as well as the tabless technology will be introduced. As we said, Elon talked about the tabless design on Twitter, and yesterday he had an opportunity to deny that this cell from Electrek was a Tesla cell, because Teslarati posted an article discussing it with photos of it in the article, saying that it hints at Battery Day being more insane than people even expect. Elon replied to that article on Twitter saying, quote, "It will be very insane," end quote. Now it's possible that Elon didn't click and actually open up the article and see those images, but if he did click on it and that wasn't a Tesla cell, you would think that he would maybe say something different other than hyping up that article. So in my opinion, larger cell, tabless design, both highly probable. Next up are the factors that will consolidate sort of under the chemistry label. So the first couple of quick hitters that we might hear Tesla talk about with a new battery cell would be the amount of silicon in the anode, which, as with everything in batteries, has a number of different impacts, but we can boil it down to a couple things. Essentially, the more silicon being used, the better the energy density. The downsides with silicon are usually that some cracking can occur in the anode that can reduce the battery performance over time and limit the number of life cycles or the number of recharges for that battery. So introducing more silicon into the anode is something that battery researchers have been trying to do for a long time. Tesla does have some silicon currently in their anode, and fingers crossed, hopefully they have figured out to add a little bit more of that over time, and if so, that is something they may discuss and talk about the energy density improvements gained from doing that. Switching sides from the anode to the cathode, a big focus on battery development has been to reduce the amount of cobalt being used in batteries. Cobalt's expensive, and portions of the supply chain can have human rights issues. Over time, Tesla has reduced the amount of cobalt being used in their nickel cobalt aluminum battery cells. A couple years back on Twitter, Elon Musk said, quote, "We use less than 3% cobalt in our batteries, and we'll use none in next gen," end quote. So, we appear to now be on the precipice of seeing what that next generation is. It's also worth noting that Tesla has recently qualified a different type of battery chemistry, lithium iron phosphate, which does not use any cobalt. It is less energy dense, but Tesla has made enough improvements in the efficiency of the vehicles overall that they can use that less energy dense chemistry for some of their lower range vehicles. So that'll first appear in the China-made Model 3 later this year. Not only will that chemistry be cheaper for Tesla, it also gives them the benefit of splitting their supply chain to some extent, because they aren't solely reliant on the materials for one particular chemistry. Because of how fast Tesla intends to grow from this point, that supply chain can represent a significant risk to those growth goals, acting as a constraint. So differentiating those supply chains helps reduce the reliance on one particular one and reduce those constraints. This is something that will play a bigger role in Tesla's future as Tesla's product offering becomes more diverse and different types of batteries are optimized for different products. So it'll be interesting to see what Tesla has to say about chemistries. I wouldn't be too surprised to see them outline a roadmap for multiple chemistries. The last point that I'll throw in here under chemistry, even though this is multifaceted, is Tesla's acquisition of Maxwell Technologies. The most relevant part of that acquisition for Tesla is Maxwell's dry battery electrode technology. This technology is a huge deal and likely to be discussed in depth at Battery Day. Traditionally, lithium-ion batteries are manufactured by producing the electrode in a wet slurry format and then coating a conducting foil with that slurry and then basically throwing it into a big oven and letting it dry in that oven. That's a pretty lengthy process. That can constrain your production rate. A lower production rate is more expensive per unit. And then of course you have to have a ton of these machines doing the drying, and that adds cost as well. So Maxwell, prior to being acquired by Tesla, had shared some information about their dry battery electrode technology. First of all, they say that it should improve the energy density of battery cells. They claim to have had a proof of concept that was completed for a battery cell that was greater than 300 watt-hours per kilogram in terms of the energy density. That's about 15% more energy dense than the batteries used in Tesla's Model 3. And then because you don't have that additional drying step, Maxwell claimed that they were able to increase production capacity density by 16 times. They believe that provides a 10 to 20% or even greater cost reduction versus the wet electrode process. So I think we'll see energy density improvements from a dry battery electrode in this new cell. And I think we'll also see significant production capacity density increases from Tesla using this dry battery electrode production process. Not specific to Battery Day, but Maxwell also believes that they have a roadmap for up to 500 watt-hours per kilogram of energy density. We're not going to get that at Battery Day. Elon on Twitter has already said that lithium-ion battery technology should be around 400 watt-hours per kilogram a few years from now. All right, so that wraps up the chemistry portion. Let's move on. Next here is cell to pack. This is another advancement that I believe is highly probable to be discussed. Tesla's battery packs today essentially have 3 levels. You begin with the battery cell, you pack those battery cells into battery modules, and then you pack those modules into the final battery pack. In the early days of Tesla, the original Roadster, those modules were there so that the battery cells would be swappable without having to take out the entire battery pack in case there were issues isolated into an individual module. But that was over a decade ago, and Tesla has learned a lot since then. That's no longer a concern, so those modules are really just taking up an extra step in manufacturing, they're taking up volume, and they're taking up weight without really serving any purpose other than Tesla already had experience manufacturing battery packs in that way. In an interview earlier this year, Elon Musk described those modules as being vestigial and said that the future is cell to pack without modules. So presumably, Tesla has designed their new battery cell to go straight from cell to pack, lowering the cost from cutting out the modules and increasing the pack level energy density both gravimetrically or weight and volumetrically or space. So that's cell to pack, and as I alluded to earlier, an underlying factor there and to almost everything that we have discussed so far has been manufacturing. Tesla's mission is to accelerate the advent of sustainable energy. To do that, they need a lot of batteries, and they need them at a very, very low cost. Tesla in the past has talked about their belief that they need to eventually ramp up their annual battery production capacity to 2 terawatt hours per year. That's 2,000 gigawatt hours or 2 billion kilowatt hours per year. So all these things, larger cells which would allow Tesla to produce fewer cells for the same amount of energy, a tabless cell design which should reduce manufacturing complexity, the dry battery electrode technology which should greatly increase the production capacity density, and going straight from battery cell to battery pack, all of these things are going to make it much faster and much cheaper to produce batteries. It's going to require less equipment, meaning less capital, and that equipment is going to be capable of producing more battery packs, which, when you put those things together, means much, much cheaper batteries. That means cheaper electric vehicles, cheaper stationary storage, more demand, which fuels the growth, which fuels the investment, which has been reduced because of these production gains. It's a viciously positive flywheel effect that when you look back on this point in history, you can start to see why this might be considered an inflection point. If all these things come to fruition, over the last few months there has been information leaking out about Tesla establishing a new battery production line near their Fremont factory, and it is aptly codenamed Roadrunner. Not only does that hint at speed, but there might also be a reference there to Roadrunner and Wile E. Coyote, the Looney Tunes characters engaged in a perpetual game of chase in which Wile E. Coyote could never catch the Roadrunner. Maybe Legacy Auto is the Wile E. Coyote to Tesla's Roadrunner. So one of the expectations for Battery Day is that Tesla unveils this Roadrunner production line to demonstrate the potential throughput that can be accomplished with all of these advancements. I believe Elon made reference to this today, as well as Tesla's other progress in manufacturing outside of batteries, when he tweeted, quote, "Speedrunning Factorio in real life, ... end quote. If you're unfamiliar, Factorio is a video game. They describe themselves by saying, quote, "Factorio is a game in which you build and maintain factories. You will be mining resources, researching technologies, building infrastructure, automating production, and fighting enemies," end quote. That sure sounds a lot like Tesla. So a lot of these are related, but I believe manufacturing and energy density at the pack level to be the two most important things for Battery Day, but it doesn't just end there. There are a few other topics that may be discussed at Battery Day. The first, which has been heavily speculated on, is the possibility of Tesla introducing a 1,000,000-mile battery. So first things first on that means a 1,000,000-mile life cycle, or another way to say that would be the ability for the battery to recharge, let's say 3,000 or 4,000 times, without having significant capacity degradation. Because I've already done a full 10 or 15 minute episode on the 1,000,000-mile battery, I'm not going to go into as much detail on that here. I'll link that episode, but the short version is that there are already batteries capable of producing that many cycles. It's just a matter, as it always is with batteries, of the trade-offs you're willing to make. For example, does that increased life cycle lower energy density or increase cost? And if so, maybe it's not worth the trade-off. In fact, Tesla already has batteries that are capable of doing 1,000,000 miles. They just don't use them in their vehicles because of those trade-offs. Rather, they use them in their energy storage products. So we'll see what Tesla has to say about a 1,000,000-mile battery. They have talked about wanting to get there with the whole powertrain in the past, which really makes a lot of sense when you bring in autonomy, because if a scenario exists where there is a full self-driving robotaxi, that vehicle is going to be traveling a lot more than 10,000 or 15,000 miles per year. If the utilization is 5 times higher or 10 times higher, then to have a useful life of 10 years or 20 years, you're going to need a 1,000,000-mile powertrain, including that 1,000,000-mile battery. It also makes a lot of sense for other utility vehicles, such as the upcoming Tesla Semi. The other wild card that could potentially add life cycles to the battery for a vehicle would be vehicle-to-grid technology. Again, we've talked about that. Tesla hasn't been super bullish on that technology in the past, so it's relatively lower on my expectations list. There's certainly value to that feature, but there's also complexity in extracting that value. So we'll wait and see what Tesla has to say on life cycle and any additional features that could drive utilization of those battery packs higher. Next on the watch list is charging capability. There's a lot of potential here. We've already seen Tesla over the years increase the supercharging rate from 90 kilowatts to 120 kilowatts to 150, all the way up to 250 kilowatts at peak now. And at the Cybertruck unveiling last November, on screen they showed a graphic that showed the charging capability of the Cybertruck at 250 kilowatts plus. Elon Musk at that unveiling said, quote, "It will be capable of more than 250 kilowatts. We'll reveal the actual number later," end quote. So maybe Battery Day ends up being that later. We know that just last week, Lucid Motors announced that the Lucid Air will have 350 kilowatt capable charging. We know Tesla's kind of competitive, so I'm not sure they're going to sit around for too long being outmatched on that charging rate. If we can get a bit speculative for a moment, one of our listeners, Florian Hayland, helped me out with this. It appears that the V3 superchargers should be capable of quite a bit more output than the 250 kilowatt max that Tesla vehicles can charge at today. To get a full understanding of this, we have to start with the version 2 superchargers. If we look at the label on those chargers, we can see the voltage listed at 410 volts, the amperage listed at 270 amps. To get the power capacity, we just multiply the voltage by the amperage, so in this case, that comes out to about 111 kilowatts. But what happens in reality is that vehicles on version 2 charge at 150 kilowatts all the time, so the amperage here is actually understated. The same thing appears to be happening with the V3 superchargers as well. On the label for those, we can see that the voltage is 1000 and the amperage is 425, so multiplying those together, we get a max power capacity of 425 kilowatts. So that's already higher than the 250 kilowatts that the vehicles can accept today, leaving some potential room for upside in charging rate. But back to the amperage, it appears that the amperage capacity is understated on the V3 chargers as well. We have a screenshot here of a Model 3 charging at that max 250 kilowatt rate, but with the voltage only at 368. So if we divide those 250,000 watts, 250 kilowatts, by 368, that gives us 680 amps, which is well above the 425 amps on the label. Right now, a Model 3's battery is limited to 404 volts, so at 680 amps, that would mean a max charging rate of 275 kilowatts instead of the 250 that is listed, but it's probably limited at 250 kilowatts to avoid overheating. If we consider a new battery though, maybe some of those constraints can be removed, and the V3 supercharger seems capable of delivering quite a bit more power than that 250 kilowatts. If we use the 680 amps here that we've already seen register out of a supercharger V3 location, and we multiply that by the maximum 1000 volts, we could be looking at a power output of 680 kilowatts from a V3 charger, and potentially even higher based on whatever that true actual limit on amps is. So none of this means that Tesla's going to suddenly unveil a battery that's capable of charging at 700 kilowatts, just that the V3 chargers do seem to be putting in place the infrastructure for higher charging to come over time. With a new cell likely being introduced, maybe we will hear more about that at Battery Day. Last couple of aspects that I've heard discussed. The first, mining. Tesla has alluded to maybe getting into mining someday, if they needed to. That's not something that I expect here from Battery Day. As should be clear by this point in time, I think they've got enough to go through without going down that figurative rabbit hole. But I do expect Elon Musk to again plead with suppliers to ramp up supply, especially for nickel. Next is a point on Tesla suppliers. We know that Tesla works with Panasonic, LG, CATL to source batteries from them. So the question has arisen of how those partnerships are going to work and evolve if Tesla is designing and manufacturing their own cell. And I think this is answered by what we spoke to earlier with product differentiation. Tesla is going to need all the batteries they can get their hands on. It's going to take them time to ramp up their own battery production. So not only can they not just convert all of their products over to their own cells instantly, even if they were to do that, they still probably need even more batteries. So they're going to continue to partner with these other suppliers. Those suppliers give them viable products, which can help Tesla grow, capture revenue, capture profit, regardless of their own endeavors in battery cells and production. As far as Tesla actually supplying these cells to others, I definitely don't expect that, not for a long, long time, if at all. And that's really for the same reason. Tesla is going to need these cells themselves. Supplying them to another OEM just adds, again, that extra layer of cost because both sides need their margin. That creates a more expensive end product for the consumer, which is contradictory to Tesla's goal of accelerating the advent of sustainable energy. So as long as Tesla is battery constrained, which I expect to be for a long time, I do not see them supplying their batteries to anybody else. Alright, so after all of this, we finally come to the product. The last thing to maybe expect out of Battery Day could be the introduction of the Plaid Model S and Model X, potentially being the first products to utilize these new battery cells as Tesla works to ramp up that initial production. It's been eerily quiet on the Plaid powertrain front for a while now, but the timing is about right, and maybe we will finally again hear something about the new Roadster. So that is almost it. There is one more thing. I have alluded to it, but I haven't mentioned it explicitly, so I'm going to put a teaser here. There is one more thing that's more important than all of the points made so far. I want that to be its own little standalone mini episode this weekend, so stay tuned for that. Let me know what your guesses on that are in the comments, as well as your overall expectations and predictions for Battery Day. We are just about there. Quick podcast update before we close it out. Tomorrow I will be doing a live stream at 4 p.m. Eastern Time, 1 p.m. Pacific Time. The plan is to talk a bit more about this episode and do some live polling on Battery Day expectations, so make sure you keep an eye out for that. But that'll wrap it up for today. As always, thank you for listening. Don't forget to subscribe and sign up for notifications. Make sure you're following me on Twitter at Tesla Podcast, and I'll see you tomorrow for the Friday, September 18th episode of Tesla Daily. Thank you.